In Learning Objective 3.3a, we're going to translate data and look at measures of center and measures of spread. So remember, measures of center we talked about in Chapter 1, mean and median. Measures of spread would have been range, IQR, and standard deviation. So consider we have these 8 students here with these various ages. What are the measures of center and measures of spread for the data? So what I'm going to do, remember, we can just go to the graphing calculator. We can do stat edit, and then we would do stat calc, and you're going to do a 1 variable stat, and it's going to kick back for us the x bar, which is the mean. It'll give us the standard deviation, which is our s of x. We're going to get Q1 and Q3, so we can get the IQR. We will also get the median from that, and the max and the min. So if you do that, here's what you're going to get, and I'm going to jot this down in the original column. So what we get is the mean and median are both 15. This is actually bimodal. There's a tie. We see 2 14s and 2 16s, and that's fine. The standard deviation, 2.07. The variance is not on the calculator. You have to remember how to find that. So remember from Chapter 1 that the standard deviation is always equal to the square root of variance. So if I know standard deviation is 2.07, and I know the square root of variance, how do you get variance by itself? Well, just square both sides. If you square both sides, you'll get the variance, and in this case, it is going to be 4.3, or let's put 285. Now, IQR, recall IQR is just Q3 minus Q1, and our range is our max minus our min. Now I want us to investigate. In part 2 here, the question is, what will happen to the same statistics if all the students were 5 years older? Okay, well that's actually easy to investigate. If you just go into, again, stat edit and do a list number 2 or list 1 again, and you type in every new age. You do 21, 17, 19, and so forth, get your new ages. Do a 1 variable stat and record it, and I'll show you what you get. The statistics will come back to look like this right here. You are actually going to see the mean went from 15 to 20, so did the median. The modes each went up by 5. The standard deviation stayed the same, the variance stayed the same, and IQR and range also stayed the same. So what we did here, you guys, is we took the original data, the X data, and we added 5 years to it. So we did a translation rule to one set of data. That's called univariate data, versus our bivariate data we did in the last chapter was an ordered pair. So that's what this chapter is about. What do you notice that happens? Well, the only thing that happens is our measures of center are actually going to change. Measures of spread are going to be unimpacted. So that's the conclusion we can make from this. So let's formalize that. Translation of data means you're going to take x plus h, or a variable, and what you're doing is you're adding a constant value to the pieces of data. Now you could be subtracting too, that would be a translation. When you do that, here's the effects of it. Adding h to each number in a data set adds h to the mean, the median, and the mode. And we saw that in our example. It does not change the range, the interquartile range, which is IQR, the variance, or the standard deviation, which remember comes from variance. Because these do not change, there's a word for it. It is called invariant. So if the statistics are invariant, means they will not change when you do a translation to them. So I want to look at 3 examples, and here's the first one. At a martial arts tournament, there were 20 fighters weighed in before the tournament. All the fighters were weighed, and the statistics were computed as following. Have it right here. Mean, standard deviation, median, and IQR. After finishing our calculations, it was brought to the statistician's attention that the scales were not correctly calibrated. The starting weight was actually set at a quarter pound and not at 0. Find the correct values for these new statistics. So you got to think about, what does our translation rule need to be in this case? How do we need to adjust this data? Well, do we take the x values and do we add 1/4 of a pound, or do we need to subtract? Well, the scale was off, so you have to subtract 1/4 of a pound. Okay, I don't have the original data. I don't need it. I just need to remember who gets impacted. Well, the mean and the median are the only values that get impacted. So if I take those and subtract 1/4 pound from both, we will get that the new mean is 190.875. The new median, 194.25. Standard deviation is not going to change, nor will the IQR, because those are considered measures of spread. So I'm going to look at 3 examples. Here's the first one. Now let's look at this example. A local produce store sells cantaloupes for 99 cents a pound. The clerk weighed 30 melons and computed the following statistics. I have them written down here. We have a mean of 3.5 pounds, a standard deviation of 8 ounces, median of 3.4 pounds, IQR of 1 pound. Now, after finishing his task, he noticed the scales weren't calibrated correctly. The scale was set 3 ounces as a starting weight and not 0. They want us to find the correct values. So we need to come up with the translation rule. So the scale was too high, so we need to reduce the value, so we're going to subtract 3 ounces. Now, you need to be very careful, because if we subtract 3 ounces, to standard deviation that'd be fine because it's in ounces, but these other 3 are in pounds. So we need to either convert ounces to pounds here or convert pounds to ounces here. But be careful, first of all, standard deviation and IQR are measures of spread. They're not going to change at all. So I'm just going to keep them like they are. Now the mean and median will. Let me show you 2 ways to do that. If we go in and we convert the ounces to pounds, what we could do is this. There are 16 ounces in a pound, so what I can do is say 3 out of 16. That's equal to 0.1875 pounds. Okay, easy enough. Then what I'll do is take these means, the mean, and I'm going to subtract that value from it, and that will give me 3.3125 pounds. And if I subtract that from the median, that's going to give me, we'll have a 3.215 pounds, and that would be our answer. But what if we wanted to actually convert maybe these guys here to ounces and just subtract 3 ounces from it? Let's just do one really quick so you can see it. If I would have done that with the mean, all I would have to do is take 3.5 pounds, times it by 16. When you do that, you're going to actually get 56 ounces. Then what you would do is just subtract the 3 ounces from that, and we could say that it was 53 ounces. If you wanted to get the correct decimal number for that into pounds, you could take the 53 and then divide that by the 16 and get the same answer that we got over here. Here's another one to try. The following statistics are related to your Chapter 1 FST test. If I want to take away 2 points, state the new values for each statistic. So let's say that means I want to actually remove 2 points from my test altogether. So the translation rule on that would just be x minus 2. What gets impacted are going to be these 3 values. Nothing else changes. So we would have 23, 21, and 22 as the new mean, median, and mode. These measures of spread would not change.